Go ahead and look at how to factor quadratics in special cases. So we're going to factor 25m squared plus 10m plus 1. So what you need to notice about this one is that the first term is a perfect square and the last term is a perfect square. So, and all the signs are positive. So that's why they're, I highlighted the signs. So to get the a and the b, when we factor, it's going to be a plus b times a plus b. So you take the first term and you find the square root. So a equals the square root of m squared, which is 5m. And then you take the last term, which is 1, you take the square root of that, and it's going to equal 1. So when I expand it, I get 5m plus 1 plus 5m plus 1. And then when I simplify that, I get, because they have the same base, each of those is to a power of 1. I get 5m plus 1 squared, and that's my solution. This is 144h squared plus 168h plus 49. So I notice right away that the first term and last term, which is a constant, are both squared. So I'm going to use this first pattern where it's a plus b times a plus b. So I want to determine my a. My a is the first term, which is 144h squared, square root, and I get 12h. And then my b is going to be the 49. So it's 49 square root, which is going to equal 7. And when I expand this, I'm going to have a plus b, so it's 12h plus 7 times 12h plus 7. And then when I simplify it, because 12h plus 7 is represented twice as a set, it's 12h plus 7 squared. 36r squared minus 12r plus 1. And we're going to choose the second pattern because I have alternating signs. I have a positive term, a negative term, and then a positive term. So when I factor this, I'm going to have a minus b times a minus b. So you're going to take the square root of the first term and then take the square root of the second term to determine a and b. So a equals the square root of 36r squared, which is r, or 6r. And then b is going to equal the square root of the last term, which is 1. And that's going to be, the square root of 1 is 1. So I'm going to get 6r minus 1 times 6r minus 1. And then when I simplify it, I get 6r minus 1 squared. Difference of squares. The pattern here is the negative sign between the two terms. I don't have a 3-term polynomial, I have a 2-term quadratic. And the first and the last term are definitely perfect squares. So I don't have a GCF. The GCF out there is 1. So when I'm determining my a and my b, to factor them, the set is going to be a plus b, a minus b. So let's see. My a is going to be the first term with the square root. So a equals w squared, and then take the square root. So I'm going to get w. And then b is going to be the last term, but it's without the negative sign. And that's going to be 16 square root, and that's going to be 4. So when I set that up, one is going to be a plus b, and then the second one's going to be a minus b. So I get w plus 4 times w minus 4. And that's my squares. Again, the pattern is going to be a perfect square as the first term subtracted by a perfect square as the last term. And only have 2 terms. So 49f squared minus 4. And we're going to create the factors a plus b times a minus b. So we're trying to make a and b. So for a, I'm going to say a equals the square root of 49f squared, which equals 7f. And then b is going to be the square root of 4, which equals 2. So I'm going to have 7f plus 2 and then 7f minus 2. And that's my solution.